Okay, today is October 10th. Hope you're doing well. I finally got the bugs out of the loading of study guides. The files were so large that we couldn't do it on our school district server. So I had to load these through YouTube. All the directions are in my newsletter. But if you still are having difficulty loading these, let me know and I'll be glad to assist you. Alright, today we have adding and subtracting wholes and decimals, and I'm going to go through a couple of things with you real quick. We're going to talk about estimation. We do that in everyday life, more so than we find exact answers. So there'll be special emphasis placed on that. There's a lot of ways to estimate in everyday life. It all depends on what magnitude of the numbers that we're dealing with as to what place we're going to estimate or round to. If I have someone that my daughter goes to McDonald's and I say, about how much money did you spend? I said the word about. That's an estimation. She said, well, I spent about $5. But if I were talking about someone's income, let's say someone like Bill Gates, founder of Microsoft, about how much is Bill Gates worth? And he would say about $60 billion. So once again, it all depends on the magnitude of the values as to what place we're round to. But we try to make it easy in 5th grade. So this is going to be our rule to estimate a sum or a difference. Round each number to its leftmost digit. Now that's called front-end estimation. That is the easiest way to do it at this level, because we get to use our same rule on every problem. We don't have to say, well, do I round up to the tens place this time, hundreds, thousands, whatever. We're going to round to the same place every time, and I'll demonstrate that in just a moment. All right. Students often think that when you round a number, all you're doing is getting an answer, then taking that answer and rounding it off. And that's not the purpose of estimation. The purpose of estimation is to make sure your exact answer makes sense, that it's a reasonable answer. Or, in everyday life, you do an estimate to get a quick answer that gives you an approximate value for what you're dealing with. Alright, so I'm going to go ahead and get started here. I'll go through these examples that I have, and then we'll go ahead and do some of the sample problems before we do some exact sums or differences. And once again, you hear me saying the term sums or differences several times. Please be aware that all students need to know those terms. Those are very important. They won't know what to do if I just said find the sum of 13 and 20. Well, they have to know that sum is the answer to an addition problem. If I said find the difference between 13 and 20, they have to know that's the answer to a subtraction problem. So those vocabulary terms are very important. All right, I'll go ahead and get started here on the examples, and I'll show you what I mean by leftmost digit and front-end estimation. All right, this example, the first example, 28,996 minus 11,964. All right, all you do, and the easiest way to do these, if you notice I've got them underlined, to find a quick estimated sum or difference, round each number to its leftmost digit. We use our regular rounding rules. That's why we spend so much time rounding. The students have to use this skill constantly throughout the year. All right, here's your rule again. Find the place to be rounded. Look to the digit to the right. If the digit to the right is 5 or greater, the place to be rounded goes up 1. Well, it is. And that 2 becomes a 3. All other digits become 0. So 28,996 becomes 30,000. The next value here that we're dealing with is 11,964. Once again, its leftmost digit is this 1 in the 10,000s place. Look next door. The 1 in the thousands is less than 5, so the place to be rounded remains the same. And then you fill in the zeros. Find the difference, and it's going to be around 20,000. Now we'll work the exact problem in just a couple of minutes down below. All right. Next, let's do a couple more of these. We'll just go right below there. That's the easiest thing to do. All right, well, let me do the next whole number. I think that might be a better deal here. All right, once again, here we go. To find an estimated sum or difference, Round each number to its leftmost digit using your regular rounding rules. The 3 is the leftmost digit. Look next door. The 2 is less than 5, so the place to be rounded remains the same. All other digits become zeros. In this value here, there's a 1 in the leftmost digit in the thousands place. The 8 is 5 or greater, so the place to be rounded goes up 1. All other digits become zeros. All right, so you've got 3,000 minus 2,000 is 1,000. Very simple. Now decimals will be no different. We're going to spend most of our time on decimals when we're studying this. We do whole numbers just to get the students back in the groove of using rules as far as adding and subtracting. So watch what I do. If you notice, every value is a little bit different, but I still use the same rule. If I want to find an estimated sum or difference, I'm going to find my leftmost digit on every problem. Once again, this is the easiest way for 5th graders to learn this rule. There's other ways to estimate, but this is the rule we're going to use. The 5 makes the 3 a 4. You don't need to add any decimals or zeros. It's just like if you're rounding $3.56 up to the nearest dollar. Well, it's $4. So you don't need decimals and zeros. 19, rounded to the leftmost digit, would be 20. 879 thousandths to its leftmost digit, the 8 would make the 0 a 1. So it's simply 1. 11 and 9 tenths. This one will not change that one, so 11 and 9 tenths to its leftmost digit would be 10. You add them up, and your approximate sum is 35. 35. Next one. This will come in to play in just a few minutes as far as a problem with subtraction for the students. If you'll notice what I've got here, I've got a whole number minus a decimal value. My estimation won't change. My rules will remain the same. To find an estimated difference around each number to its leftmost digit. Well, this one will stay the same. That's pretty obvious. 40 will remain 40. The 6 is in the leftmost digit. The 7 will make the 6 a 7. You subtract, and there's your answer. All right, now I'm going to go through a couple of problems down below here before we get into the meat of this study guide. And I'll just show you a couple of problems that the students face. All right, first problem. We're going to be finding, by the way, sorry. You're going to find estimated sums or differences. All right. The easiest way to do these is to work right below. If you're only doing the estimation, you don't need to line these up necessarily. Matter of fact, it's easier if you don't, because you can work right below. All right. If I were advising the students to get an estimated sum or difference, I would go ahead and underline my leftmost digit. Get that done. Get that taken care of. Then work right below the problem. Or right above it, either one. All right, the 4 is next door to the leftmost digit. The 4 will not change the 3. So that is a 3, and you bring down your zeros. 30,000. 23,112, same thing. The 2 is the leftmost digit. The 3 will not change the 2. So you've got a 2. And you fill in with zeros. So what you've got here is, and it's a little crooked here, but sorry, you've got 30,000 minus 20,000 is 10,000. And you're done. You should be able to do an estimate within 10 seconds or so of getting your problem given to you. An estimate should be quick, and it should be an approximate, reasonable answer for what the actual sum or difference is. So you want the estimate to be easy to find, quick, and fairly reliable in most cases. Alright, let's do this one. And I'm not going to do all these just like I didn't do on my decimal concepts test, but I will do enough to give you an idea of what to do. Alright, I'm going to do this again. I'm going to underline my leftmost digit. My rules will never change throughout, so I'm going to use the same thing every time. Alright, my rule says to find the place to be rounded look next door. That 9 will make the 1 increase to a 2. I'm working right below my problem again, as you notice. So I've got 200,000. If I had $199,998 and I rounded that to its leftmost digit, it would be $200,000. All right, now I've got a 4 leftmost digit. I look next door. The 8 is 5 or greater, so it makes the 4 turn into a 5. These become zeros, and 200,000 minus 50,000 is 150,000. All right, now let's do a decimal. Once again, I can't work all these because it would take forever for you to get through these, and it'd be pretty boring to watch me work every single one, so I won't be doing that. All right, let's skip down here and do this problem here. Let me make it just a little bit larger. Once again, as I work through these, if there's a pause in the action, it's just because I'm having to manipulate the board just a little bit, and I have to go back and forth to my computer sometimes, so pardon any kind of pauses. Okay, let's make it just a little bit bigger. Alright, now let's do this problem right here. I'm going to work right below it again. I'm estimating 39 plus 3 7/77 plus 19 76 This is where students mess up, and you're going to see that in just a moment. I'm going to show you the major problems that students face when they add or subtract wholes or decimals, but mainly decimals. This is why estimation is so important, because the students can get an estimated sum or difference, then look at their real answer, and I'm going to deliberately make a couple of mistakes in a moment, and you're going to say, the students should be able to say, you know what, I've done something wrong here, because my estimate is nowhere near what my actual answer should be, and I'll demonstrate that as we get on down here. All right, first of all, I've underlined my leftmost digit. An estimate should be quick, easy, and a reasonable, approximate answer that will give you a good idea if your real answer is correct. So, I've got 40, I've got 4, and I've got 20. That was quick, it was easy, and this answer is going to be roughly similar to what the real answer is, even though we're just rounding to the leftmost digit. All right, I've got the 9 makes 3 of 4, the 7 makes the 3 of 4, the 9 makes the 1 of 2. Now if you notice I don't have any decimals, any zeros, I'll leave it 40, 4, and 20. Add those up, I get 64. Okay? Let's do this one here, then I'll get down and I'll show you some of the problems that the students will encounter. Leftmost digit, leftmost digit, leftmost digit. The 0 will not change to 3, so I've simply got 30. The 7 makes a 0 a 1, so I'll leave it 1. If I mark through this, and let's say this were money, and that were 74 cents, and I said, well, what would that be to its leftmost digit? Well, that'd be $1. The 2 will make the 1 stay a 1, so it's 10. 30 plus 1 plus 10 is 41. Okay? So you can see that these work out very quickly, and when we work the one on the left, this one here, you're going to see that my answer is a pretty good approximation to the real thing. All right, now let me show you the problems that students face. I'm going to go through the rules with you real quick, and then we'll do a couple. To find the exact sum or difference, line up each number by its place values. Or if there are wholes and decimals, now this is critical right here, if there are wholes and decimals, mix together, add a decimal to the end of the whole number. Add a decimal to the end of the whole number, and I'll show you that in just a minute. Before lining up, when adding or subtracting decimals, line up the decimals, bring straight down, and then add or subtract as with wholes. When subtracting a decimal from a whole, Add zeros at the end of the whole before beginning to subtract. These rules must be followed or errors will occur. And you're going to see that because I'm going to make one on the very first problem. I'm going to go back to this original problem that we did here. If you'll remember, when I did this problem and I got an estimation, I had 40 plus 4 plus 20, which is 64. Okay? So I would like to think that my real answer is going to be close to that. But I'm stubborn and I don't think I need to follow these rules because it doesn't matter. They're just a bunch of digits slapped together and it doesn't matter a bit. But I try to tell the students, if this were your money, it would matter then. So even though we're just doing things on paper, take it seriously because at one point in your life you're going to be doing these and it will be a more important endeavor for you. All right, here we go. I'm going to make the most common mistake that students make. The rules say to find an exact sum or difference. Line up your decimal places. Well, here's the problem. I don't have a decimal on 39. Well, we assume 39 is a whole number because there is no decimal. We've learned that a whole number is always to the left of a decimal point. Well, in everyday life, we don't put decimal points on all of our numbers. If I see 39, I'm assuming it's 39 wholes. Well, here's what students do. They say, well, I don't see a decimal, so I'll just put it right there. That's okay. It doesn't matter. Well, I'm going to work it now, and you can see that it does matter. As I said earlier, this is one of the more common mistakes that the students make. Well, I'm going to add this up now. And I've got 16, and 6 is 22. I've got 10, I've got 12, I've got 7, I've got 19. 1, so there's a 3. And I've got 23 and 92 hundredths. Well, I didn't pay attention to my estimate. I did it because my teacher told me to find an estimate. And then what I don't do is I don't look back to see if they have any reasonable connection to one another. Well, here was my estimate. I had 40 plus 4 plus 20, and that's 64. Well, realistically, this answer should be pretty close to 64. Well, it's not. It's not even anywhere close to 64. Now, you'll find the bigger the numbers, the greater the spread between your estimate and the exact answer. But right here, these should be relatively close, and they're not. Well, we know what mistake I made, but the students, if they'll look at the exact answer in comparison to the estimate, they're going to find or catch the mistakes that they make. All right, so let me do it the way it should have been done. Well, first of all, my rules say if there's no decimal, add it to the end of the whole. All right, you've got to add it. Well, when I do that, then I follow my regular rules, which say this. To add or subtract decimals, line up your decimals by place values. The decimals have to line up. Now, everything's just going to fall into place, nice and neat here. All right, now I can add it, and I'm going to get a right answer. I hope, unless I make a careless mistake, which I do that frequently. And I've got 13, I've got 15. You bring your decimals straight down when adding and subtracting. So there it is. I've got 10, and I've got 12 more, I've got 22. Add these up, and I get 62 and 53 hundredths. Now, my estimate was 64. My exact is 62 and 53 hundredths. All right, that is only 1 and 47 hundredths off my actual answer. Now, that doesn't guarantee that I've got this correct. That doesn't guarantee that at all. But it does guarantee that I followed my procedures properly as far as my decimal points. And hopefully I've eliminated that as a possible trap for me. All right, let me do one more of these. All right, let's do this one here. And I'm going to show you the proper procedures, and then we're going to do one a little bit more difficult. All right, I'm adding 3 decimal values. All right, I'm going to get an estimated sum first. Then I'm going to get the exact. All right. I've got 2 3/10 plus 8 9/10 and 6 785 thousandths. To get an estimate, I round each value to its left digit. The 3 will not change to 2, so I have 2. The 9 changes to 8 to a 9. The 7 changes to 6 to a 7. So I've got my answer already. I've got 2 plus 9, 11, plus 7 is 18. So my approximate sum is 18. Well, I'm going to do this one right. I'm not going to make a mistake on this one. I'm going to line up my decimal points, and then my place values fall right into place. Now, we tell the students, or I tell the students, if you want to add zeros here, when you add, that's fine. If it makes it look better, that's fine. You don't have to do that, but you will have to do some of this on subtraction. But if that helps you, go ahead and do it. All right, I'm going to add this up. Okay, and I've got 17 and 985 thousandths. Now, if you notice how close these are, as I told you earlier, the smaller the numbers, your answers are going to be, your estimate and your exact are going to be a little bit closer. When you get bigger numbers, they may be a little bit bigger spread between them. But see, this is only 15 thousandths off the actual answer, and that's pretty close. And we just did it by doing a quick estimate. So you can see this does work using front-end estimation, which is rounding to the leftmost digit in each value. All right, I'm going to go down and show you another problem that the students will face. Now, there's one of the problems we did earlier. This one right here. I'm going to show you this one and show you what can happen if you don't follow the rules that are up here. Now, when subtracting a decimal from a whole, right here in our rule, excuse me, when subtracting a decimal from a whole, add zeros at the end of the whole before beginning. Kind of hard to manipulate this thing when it's that big, before beginning to subtract. Now, once again, you think that wouldn't make a difference, but it will. And I'm going to show you the common mistakes that students make. All right, let me get back to my problem here. All right, where is it? It's over this way somewhere. There we go. Here we go. All right. 25 minus 4 and 567 thousandths. All right, I'm going to get an estimate first. Once again, my estimate should be quick, easy, and fairly reliable. I'm going to round each number to its leftmost digit. All right, that's around, the 2 will be changed by the 5. The 5 makes the 2 a 3. So that's around 30. That's good enough. The 5 makes the 4 a 5. My answer should be around 25. Now, we know it won't be because I started out with 25. And if you take anything from 25, you're going to have an answer less than 25. But once again, we've got to be consistent with the students in this case at 5th grade. We've got to use the same rule because I'm not going to start saying, well, let's round this one to the ones place. Let's round this one to the thousands. So to make it easier on the students, we're going to do the same rule every time. Leftmost digit when we estimate. All right, now here's the mistakes that students make. By now, they should know to put a decimal after the whole number. 25 is a whole number simply because it's to the left of the decimal. If you don't see the decimal, you have to put it in. So you got 25 here. That's what made it a whole number. Now, I'm going to line up my next value right below it. All right, now this is a common mistake, and I'm going to show you what they do, and I'm going to show you, if you first look at it, it doesn't make sense why students do this. But to them, it does make sense, so we have to look at it from their perspective. They don't see anything up here at all. They don't see anything right there. So they say, you know, there's nothing there, so I guess I'll just bring these things straight down. And then I'll go ahead and subtract. And they assume they did just fine. because their estimate was reasonable. They look at it and say, that looks pretty good to me. Well, it's not. I'm going to give you a simpler problem, and I'm going to show you when I deal with money, the students immediately pick up on it. Let's say I'll go to McDonald's, I've got $5. Well, I spend $3.25. I go home and my mom says, well, how much money did you spend? Well, they say, look, I even did the math for you, Mom. I brought down my 25, I subtracted, and I got $2.25. Well, if you look at that, something just doesn't look right. I started out with 5, and I spend $3.25, but I've still got $2.25 left over. Now, students have been taught to check a subtraction problem, add the difference back to what's being subtracted. And if you've done everything correct, you should get the answer, the number that you started with before you subtracted. Well, let's do that. Well, I'm going to add those back, and I'm going to get this. Well, I didn't start with 550. I started with 5. So what happened? Something is not right. I did something incorrect, and I need to figure out what it was. Well, this is what I did wrong. I failed to realize that you just can't bring numbers down when you're subtracting. That just doesn't work. You've got to have something up there to subtract them from. So what the proper procedure is to add zeros. Whoops, let me get this going here. There. Now look at it and you say, wait a minute, let's see, this should work now, and it will work. Now I'm going to do the easy one first. I'm going to put my zeros here. I'll get rid of this answer. Get rid of this answer. Now I'm going to actually get the correct answer because I'm using the correct procedure. If you don't have anything up here, you add zeros, because you can't take something from nothing. You've got to have something above there. All right, now here's another problem. Here's another issue, is regrouping. All right, first of all, before I subtract, I'm going to bring my decimals straight down. To add and subtract decimals, bring your decimals straight down, then add or subtract as you would with whole numbers. I'm going to have to regroup. I don't have enough of these to take that away from it, so I've got to help from here. Well, when I don't have anything there, so I've got to go all the way to my whole number to bring something over. Now, I'm just going to do this quickly, and then I'll explain what I've got. All right, I had to bring over one whole to help these numbers out. When I did that, I have to have 10 in the ones place. That left, when I bring this over, that only leaves 9 tenths here. 9 tenths, excuse me. 9 tenths left. So I've got 4 wholes, 9 tenths, and 10 hundredths. If you add these together, you got 5 wholes. Subtract. Now, let me bring that down a little bit so it looks more reasonable. This makes sense. If I go to McDonald's with $5 and I spend $3.25, I ought to have $1.75 left. If I add $1.75 back to how much I spent, I will get my $5. All right, so let's go to the problem that we're currently talking about. Get rid of all this here. All right, let's, now we're going to get an answer that's reasonable. Once again, I cannot take something from nothing. So I've got my zeros here. Now I've got to regroup some. And 5th graders and adults still have difficulty with this. And I understand that. Totally understand it. But it's something that you just have to get through and keep practicing. Alright, I'm going to regroup everything at once. I like to go ahead and do that. Since I've got to bring it all the way over from here, I'm going to do all my regroupings at the same time. It just makes it easier. In other words, if I bring a 10 over here, I've only got 9, 9, and 4. Now, let's see if that's right. 5 wholes is worth 4 wholes plus 9 tenths plus 9 hundredths plus 10 thousandths. If you added all these together right here, you're going to get 1 whole. So that's a good way to double check yourself. 10 minus 7 is 3. 9 minus 6 is 3. 9 minus 5 is 4, excuse me. 4 minus 4 is nothing. 2 minus nothing is 2. Now, that answer, I don't know if I'm right. So what I can do is go off on my paper and check it. Just a good practice to get into, and I know students don't like to do this either, because it's one more step that they've got to get through. But I'm going to add these together now and see if this answer is correct. I'm hoping it is. 3 plus 7 is 10. Put down my 0, carry my 1. 1 plus 3 plus 6 is 10. Put down my 0, carry my 1. 1 plus 4 plus 5 is 10. Put down my 0, carry my 1. If you notice, I brought my decimal straight down again. 1 plus 4 is 5. Bring down my 2, and I'm right. Okay? Excuse me. Now, I've checked it there, and you can see it works. Now, in real life, adults, we check things. I mean, if you're like me, you check your bank statements, you check your bills, you check other things for accuracy. Right now, a lot of the students, all they see is numbers on a piece of paper, and it's not as critical. The only thing that they worry about is a grade on a test. So it's a little bit different. In our case, as adults, this would be the difference between having maybe a check bounce or something like that, or being billed double for something. So our perspective is different from theirs. Right now, all they see is, oh, that's a problem. I need to get an answer to satisfy the requirements of a test or a grade. And they don't see that as a real life problem. So what we have to emphasize to the students is that this is their job, and their job right now is to make sure that they do take this seriously, and they don't take it so lightly that they get careless and not follow their rules. The rules are there to help them, and I encourage you to make sure your child understands this. The rules are not there as punishment, they're there to help them. Now, let me go through just a couple of these, because I know you get tired of watching these after a certain point. So I'm going to mainly concentrate on decimals. I'm just going to do a couple, because we'll be doing all of these in class. Let me remind you, your child does not have to do any of these problems at home. We work them all in class, every one of them. Your child's going to get 2 study guides on Monday the 10th. One of them is this document right here. We will do all the problems in class. Now, some of them like to do them at home, and that's fine, but you don't have to. Never feel obligated. The next one is just a set of problems that will be practice problems, and I like to have the students keep sample problems together so we've got them all in one place. Then they'll have 2 different guides that they can look at and refer back to make sure they understand the concepts. All right, I'm going to do, let's just do this one right here real quick. And I'm going to do both estimated, summer difference, and exact. And I'm not going to do that many, but I want to do enough to make sure you and your child understand together the proper procedures. All right, here's my estimate. Leftmost digit, leftmost digit, leftmost digit. The 0 will not change to 3, so I've got 30. The 7 changes to the 0 to a 1. The 2 does not change to 1, so I've got 10. So I've got my 41. Now, that's my estimate. To add, the main thing to remember is to line up that decimal point. If you don't do that, there's no way you're going to get it right. Absolutely no way. Now, 12. If you noticed, I'm deliberately putting problems on these practice guides to challenge the students to use their rules. I see 12. I cannot put 12 here. Let me get a different color. I want to emphasize this. Come on. All right, there. I can't put 12 there because that says it's 1200s. Well, it's not 1200s. It's 12 holes. So the students have to remember that decimal has to go there because it's 12 holes. That's what tells it that it's a whole number. So now I'm ready to add. I've got my decimals lined up, I've got all my place values lined up. All I've got to do is add as I would with whole numbers. And I'm done. Now if you notice, now I'm working fast. Hopefully I won't make a mistake. If you catch me making a mistake, once again, pardon me, because I usually do these on Sunday. And I try not to make them too long, but so if I make a mistake, please forgive me. All right, here's my estimate, 41. Here's my exact 43.2 and 263,000. So that's reasonable. All right, let me do another one. Let's do another subtraction here. Let's do this one right here. This one, watch how quick I get my estimate. All right, this is 90 minus 8. Well, 90 minus 8 is 82. That was quick. That's how quick you should be doing an estimate. But if the students don't follow the correct procedures, they're going to mess up on the actual difference. I've added a decimal to 90 because it's a whole number. By definition, it's a whole number because it's to the left of a decimal. So I add it. My other place values fall right into place below. Now, I can't just say, well, there's nothing here again. I bring down my 21. You can't do that. So what do? Well, I'm adding my zeros like I did in the previous problem. Now I can get an exact answer. I'm going to have to regroup again. I do it all at once. Since I've got multiple zeros, I just make a habit of going and getting it done. Here I go. 10 minus 1 is 9. 9 minus 2 is 7. My decimal comes straight down. 9 minus 8 is 1. 9 minus nothing is 8. Now I've got 81 and 79 hundredths. Now am I right? I'm going to take what was being subtracted. I'm going to go back and line these up. And I'm going to check it. I'm sorry, that's hard to see. Let me change colors. 1 plus 9 is 10. Carry 1. 1 plus 2 plus 7 is 10. Carry 1. Bring your decimal. And there's my 9. Let me do one more maybe. Let's see if I can find, okay, let's do 233 minus 23 and 23 hundredths. All right, here's my estimate. Real quick, real short, real sweet. Leftmost digit, leftmost digit. 3 doesn't change the 2, so I've got 200. Very easy. The 3 doesn't change the 2, so I've got 20. So my estimate, that's around 180. That's good enough. That's good enough. Okay. Once again, it's not, if it were me and it were you and we were buying something and I said, look, $233, something is 10% off. I'd probably say 230 maybe minus 20 and get 210. You can see that's a bit different from that. But in 5th grade, if we start switching our rules, it's more confusing than anything. So we're going to do leftmost digit every time. All right, here we go. Here's the exact. All right, 233 is a whole number. First thing I'm going to do is put a decimal after it. I'm going to line up my place values. And as you can see, so again, I've got a 23. I don't have anything above it. So first thing I'm going to do is add zeros. If this were money, that's what you do with money. So encourage your child to make sure that's taken care of before they subtract. All right, now I'm going to regroup again. I've got a 10. I've got a 9. Now this is a 2. All right, we're going to leave that. We're not going to worry about that one yet. Because I borrowed from that one, I'll have to regroup again, and you'll see that. 10 minus 3 is 7. 9 minus 2 is 7, excuse me. Now, I come to this one, I say, wait a minute. I've got a 3 here and a 2 there. I can't do anything to that. So I've got to regroup again. So I'm going to bring something over from here. 12 minus 3 is 9. 2 minus 2 is nothing. And 2 minus nothing is 2. Now, what have I not done? If you look at it, you say, well, that's 20,977. something's not right. Well, the most, one of the more common mistakes is just forgetting about your decimal. It's got to come straight down. Remember your rule says add or subtract decimals. Line up your decimal points, bring your decimal straight down, and then add or subtract as you would with wholes. And see, now I've got it ready. Now, I don't know if I'm right though. This is a big problem, so I'm going to check it. Just to make sure, especially when you regroup. Even as adults, we make mistakes all the time regrouping, and you know that's true. It's just so easy to make those mistakes. We have calculators to guard against those mistakes, but sometimes we don't have a calculator, so we need to be able to check by hand. All right, now I did do the problem correctly. All right. I'm going to do just one more quick thing, and then we're going to wind it up today. All right, if you notice, there's some little word problems down here at the bottom. We'll do these the same way, but the terms or the words in these problems you need to notice. What is the estimated difference? Here, you don't see the term estimation, so it'll be an exact. How much money does he have left? It doesn't say about how much money. How much do they need? All right, once again, you've got, before you start doing a word problem, you've got to know what they're asking you to find. Is it an estimated sum or difference, or is it an exact? So it's the student's job to read through those carefully. All right, I'll do a couple of these real quick, and that's going to do it for today. I'm not going to do anything on the other study guide, because it's mainly practice problems. We'll do those in class. The main thing I wanted to accomplish today was to make sure you could see the rules in action, and if you're looking at this with your child, that y'all can talk about these rules together. All right, here we go. Let's just do the first one. What is the estimated difference between 298 and 785 thousandths and 207 and 981 thousandths? Well, have to know what a difference is. Difference is the answer to a subtraction problem. You have to know how to estimate. We're using front-end estimation, which means we're going to round each to its left digit. The 9 makes a 2 a 3, so I've got 300. The 0 doesn't change the 2, so I've got 200. So my answer is 100. Very quick, very easy. We'll do one more problem here. Let's do the second one. This one says, Jane buys a pen for 89 cents. Now, once again, as adults, we see money all the time. A lot of students see that, and they get it confused with this. Okay, let me clarify that real quick. This actually says 89 hundredths. This says 89 hundredths of a dollar, which is 89 cents. Now this says 89 hundredths of a cent, which is only part of 1 penny. So this is incorrect. Now what made it incorrect? Well, that decimal did. So now I've got it correct. So these are the same things right here. So just make sure everybody's on the right, same page with that. All right, let's do this one. I buy a pen for 89 cents, a notebook for $4, and 2 erasers that cost, sorry, too many things to do on this board, that cost 59 cents each. How much did she pay in all for these school supplies? Well, in all means I'm probably going to be adding, so let's get started. A pen for 89 cents. Put your decimal. Now, a notebook for $4. Well, once again, I put this on there for a reason. I want to make sure the students understand that $4 is written 4 in my decimal. Now, you can add zeros here if you want. It doesn't, it's not critical, but if it helps you, please do so. Let me move my problem over so you can see the rest of it real quick. And 2 erasers that cost 59 cents each. So I've got 2 of them. Now, the students have not studied multiplication of decimals yet. We will. But for now, the easiest way for them to do that is to realize, hey, I better put 59 cents down twice. So now I can add it. I'm going to get an answer. I've got 3 9s, which is 27. I've got 10. I've got another 10 right here, so I've got 20. So I've got 2, and I've got 4, and I've got 6. Well, I've got $607. That's a lot of money to pay for those school supplies. I bought a pen for 89 cents, a notebook for $4, and 2 erasers for 59. Now, once again, I've made a common mistake. I failed to bring my decimal straight down. And now it makes sense. All right, this video will be archived for as long as you need it. So if there's something on here that you need to watch later in the school year, just refer back to it. I've given you instructions on how to access the videos quickly. You can get to them other ways, but that's probably the quickest way, so you don't have to Google in titles and all. Just go to my videos section and it should help you. I hope you have a good evening. Contact me at any time you need some assistance. Email me, call me, send me a note, or you're more than welcome to come in and visit. I love to have parents come into the classroom and visit with us, and I think your child would like that as well. I hope this has been a benefit to you. Thank you.